Hi everyone, I'm Andrei Krichevskiy, I'm software engineer in Team Power, and today I would like to talk about reactive streams. Let's start with the simple examples. We have two services, producer and consumer. And if producer way much faster than the consumer might become very slow and eventually burn down. And upgrading or scaling out consumer sometimes is not a viable option. Let's see how can we improve this situation. The first option we could do, we could introduce a circuit breaker on the producer side. How does it work? In normal operation, circuit breaker is closed and all the requests are going from producer to consumer. If circuit breaker sees that there are some errors or slow responses, it just opens up and gives a chance to downstream to recap. And then after some delay, it starts probing and see if downstream managed to recover or not. If it's recovered, it just closes and allows requests to pass through, otherwise it still becomes open. Circuit breaker is a very nice abstraction. It works, but it does not know precisely how downstream is doing. It does a little bit of guesswork. And let's see if we could do it even better and eliminate this guesswork. Let's switch to async communication or messaging between upstream and downstream. And also let's introduce a buffer on the consumer side. Async or messaging is a very good way because this is decouples in time consumer and producer. There is no waiting, there is no blocking, there is no wasting of CPU cycles. But buffer has only one problem. It can overflow. What we could do with buffer overflow? There are several options. First of all, we could drop all the messages which do not fit the buffer. It's not good because we'll get data loss. Another option, what we could do, we could drop the messages and ask upstream or producer to resend them. That's how kernel works, that's how TCP works. But this can bring even more load on a slow consumer. Then, there is option number 3. We could increase buffer size, but we cannot do it infinitely because we're having a risk of out-of-memory errors. Let's see if we could improve something about buffer. We could introduce a feedback mechanism, this is green arrow on the slide, which is called backpressure. How does it work? Consumer knows for sure how many empty slots it has in his buffer. In this case, it's 3. And via feedback, via backpressure, it asks producer to send exactly 3 items. And producer obeys these contracts and sends no more than 3 items. What producer does with the rest of the traffic? It simply backpressures it in the similar fashion to his upstream, and it goes over and over again until it reaches end user. So, backpressure, together with async processing, is what reactive streams are. They give us better system resources utilization. There is no blocking, there is no waiting, there is no guesswork. This allows us to spend less money on our hardware and data centers. The good thing about this is that you don't need to implement this from these reactive streams and backpressure from scratch. There are quite some implementations. This is JVM implementations. They exist also in Java languages. So just pick any, read more about it, and start using it. And last but not least, I have a small example over here. Basically, there is a web server which does, with reactive stream supports, which does very useful thing. It produces random numbers, random integers. And there are 2 clients. There is a fast client on the left, or fast consumer, and slow consumer on the right pane. On the slow consumer on the right, it can get only 50 bytes per second. And now we'll start them, and you will see how server will manage to decrease its emitting rate, you see, to the slow consumer. This is exactly the same producer, but different clients. One fast, one slow. That was pretty much it. Thank you very much for your attention.